In this video, we are going to review some of the things about arithmetic sequences. A reminder, an arithmetic sequence is a sequence sequence of numbers which, to find the next number, we are always adding the same number each time. So for example, if I gave you the sequence 4, 10, 16, 22, 28, that goes on forever. You notice to get from 4 to 10, we added 6. To get from 10 to 16, we added 6. 16 to 22, we added 6. Each time we're adding 6 to get the next number. This next number we are always adding, we call this the common difference. Because we get that difference, we call it common because we're always getting the same number. It's a difference because we're always taking a number, whatever our current step is, and subtracting the one that came right before it. So now versus previous. It's always the same. That's our common difference. Then it's an arithmetic sequence, and we call this common difference the rate of change, which is the same thing as our slope when we look at linear equations. So if we were to give you a different sequence, let's go 10, 7, 4, 1, -2. We're looking at our common difference. We would take 7 minus 10 is a -3. We like to think of that as we're subtracting 3, but we can also say we added a -3, because 4 minus 7 is again -3. 1 minus 4, -3. So here my common difference is a -3. When we're doing this, talking about writing our formulas, let's move this one out of the way. Not the eraser. This is what I want. Here we go. We're going to cut this and move it down here. Work with this one later. Moved it down too far. Confirm. Okay, when we're trying to describe this and write a formula for this, we're going to write what we call first our recursive formula. So in this case, we're saying recursive means what do you do to find the next number? We're using the last number to find the next one. To do a recursive formula, we always have to start off with what was our first number. So in this case, our first number is 4. What do we do to get our next number? So then we say f of n for any number in the sequence. To find any number, I have to take the number that came right before it. So for example, if we say this is my first number, this is my second, this is my third, if I wanted to find the third number, I'd need to use the second number and add 6. So I say to find any number, I take the number that comes right before it, and I add 6. Now this only works if I'm looking for the second number or greater, because for the first number I can't add the number that came before because there's no number that came before it. We also want to do what we call the recursive formula. The explicit formula. So for the explicit formula, I don't want to, say if I wanted to find the 10th term, I don't want to have to work up and find all 9 terms before it. Recursive, I can make the table, because I can always find the next number. Explicit, if I just want to get one out of the blue, that's the nice thing. So, for example, if here's the 3rd, the 4th, 5th, if I wanted the 6th number, what I could do is say, well, I started with 4, and I added 6, 1, 2, 3, 4, 5 times. So I added 6 5 times, or I added 30. This is kind of the idea of the explicit formula. The explicit formula, I can say f of n, I started with 4, and I'm adding 6, but how many times did I add it? Well, to do it the 6th time, I added, again, 1, 2, 3, 4, 5. So if n is 6, I want to add it 5 times. I go n minus 1 here. Now, it's a little easier if I actually did have a 0 term. If I said the 0th, I could take this 4 and minus 6 to get a negative 2. I could start with negative 2 and add 6 just n times. Because then if I wanted the 6th number, I would add 1, 2, 3, 4, 5, 6 times. We get that explicit formula. So if I have, this is when I have the first term, I have to have n minus 1. If I have the 0 term, I can just add n. Looking at the same one way with this one, we will do this recursively. So recursive, our first number is 10. Our any number in the sequence, we're going to take the number that came right before it. And in this case, we're subtracting 3. So again, this is where I start. This is to find my next number. F of n minus 1 is my last number. And that's my rate of change. To do this explicitly, I would just say f of n equals, I started with 10, I'm subtracting 3, but since 10 was, again, this is the first term, I'm going to make this n minus 1. And I can use this anytime I'm 1 or bigger. I can use this to find all of them. So, kind of to sum everything up, when we're doing arithmetic sequences, again, we're adding the same number each time. What did I go? Let's go to here, tools. That's not what I wanted, so this is what I want. Okay, so again, arithmetic, we're adding the same number each time. And that number that we're adding each time we call the rate of change. And the rate of change, again, we get by taking now minus previous. So we can write this either recursively or explicitly. So I'm giving you, on all of these examples, I'm using A to represent the 0 term, C to represent the first term, because sometimes we start with term 0, sometimes we start with term 1, but B is always that rate of change. So when we do recursive, it looks pretty much exactly the same, whether I start with the first term, C, or I start with the 0 term, A. I just give you what number I'm starting with, and then to find the next number, I take the previous number, or the last number, and I add my rate of change to it. Only difference is how I'm numbering them. But when we get to explicit, it does make a difference. With explicit, if I started with the first term, I'm going to use n minus 1 here. What number we started with plus the rate of change times n minus 1 if this was the first term, but only times n if it's a 0 term. So for explicit, it's really important whether you have the first term or the 0 term. So let's give you a chance to try some of these. So for these 3 examples, see if you can write the following in explicit form. So pause the video, try to do the 3 problems, and then unpause it, and you can see what the answers will be. Okay, on this one, we're subtracting 4 each time. I need to switch that. We're subtracting 4 each time, and we have the 0 term. So we can say f of n equals 25. We subtract 4 each time, and we can just use n because I had the 0 term. On the second one for r, r of n, I have this 4.35, but it's the first term, not the 0 term. I'm adding 8.37. But since I had the first term, not the 0 term, I have to take it times n minus 1. For g, I have the 0 term. So when I write this one, I again start with my 19. I'm subtracting 12 each time. But again, I have the 0 term, so I can just say 12n.